Hello guys, welcome back to my YouTube channel. Now we are going to solve minimum x or a. The discussion says that we are given two integers a and b. The task is to find an integer x such that x or a is a minimum possible, and the number of set bits one's complement once in x is equal to the number of set bits in b. Now in other words, we want to transform into a new integer x that has exactly the same number of 1 s and b as b, while staying as close as possible to in a term of x or a value. Now let's think like if a is equal to 3 and b is equal to 5, then the binary of a will be 0 1 1 and the binary of 5 will be 101. So b has 2 bits and a also has 2 bits. So the best choice is x will be equal to a, and that would be 3. So the output will become 3 as explained here. Now let's do the coding. If you get the understanding, you will get the understanding by the reading of the question, because question is not so difficult at all. So let's start solving the question. Now we are going to make our helper function def count bits, and we provide the parameter here is x. Now we want return our bin of x dot count, and that will be our 1. Okay, I made some mistake here because that will be bin of x, so that's good. Now now let's make some variable set bit. We are going to set the bit in our b, and that would be our count bit, and that would be b, right? We are going to set we are going to required we are required to set bits from b, and the next will be currents. We are going to current set bits in a, so that would be very simple. We are going to set bit in a would be equal to, sorry for that, count a would be a. Okay, no problem here. Now we are going to declare our x is equal to a. That would be start with as the base number. Now the case 1, our case 1 will be, we are going to, if we has more ones than required, then we are going to check if our set bit in a is greater than set bit in b. That is a long variable name, I guess. Now for I in range 32, and sorry for that, I do mistakes in typing, so remember that. If our set bit in a is equal to our set bit in b, then we are going to break our loop, and if our x and with 1 greater 1 shifted to I, if that's the case, then we are going to decrement our big X by 1, sorry for that, 1 shifted to I. And now set bit in A will be decremented. Now we are going for case 2. If A has a fewer ones than required, then I'm going to use elif. Sorry for that, elif should go there. Elif set bit in A is less than set bit in B for I in range 32. Sorry for that, I make mistake very much. If set bit in A is equal to again set bit in B, then we are going to again break because we don't want that. And if not not our big X and with 1 shifted to I, if that's the case, then we are going to increment our X by 1 shifted to I, and we are going to increment our set bit in A by 1. Now we are going to simply return our X, and let hope I didn't do any typo at all, because I do that. As you can see, our case is completed. Now let's run the code for to be completed for all the cases, and as you can see, our all cases has been passed. Now let me again explain all the steps that I used. Firstly, I make helper function here, and that helper function is used to count set bits in a number. That would be okay, right? And now this line set bits in B means we require to set bits from B, and that line means we are current set bits in A. Now that line that X is equal to A means we are going to start with A as the base number, and from here our case 1 is started. Case 1 is if A has more ones than required, then we are going to put the condition here. If our set B in A is greater than our set B in B, then we are going to check all the 32 bits by doing the range, and we are going to stop when match achieved. If we find the match, then we break the loop. And if we don't find the match, right, if we don't find the match, then we check again, like if bit I is set, right, and then we turn off the bit I, and then reduce the count of ones, right. Now for the case 2, there is a case 2, and case 2 means if A has a fewer ones than required, then we are going to put the condition again here, and that condition would be like opposite from that. And now we are going to check all 32 bits, and we stop again when match achieved, and if not achieved, then we are going to that line means if bit I is not set. If it is not, then turn on bit I, and then we are going to increase the count of ones, and at the end we are going to return the integer with minimum XOR or XOR. So that will be the explaining of this code. And if you guys like my video, then subscribe my channel, like, comment and share as much as you can. I have uploaded many videos for coding interviews question for specific companies, so you can also access that from my YouTube channel, from my YouTube page, or also the description of this video. And if you like laptop videos, then also you can watch. I just uploaded 3 videos maybe, so you can watch that. I upload videos because I have a keen interest in hardware of computers, so that's that, because I like computers. And if you guys want more laptop or computer videos, you can ask me. I will serve the request. And I know no one can watch at the end of the video, so that's that. And sorry for that. I was I would say not active so much on YouTube these days, because I have joined the company, and I was fresher at I was graduating from the college, so I got the company. So because of that, I was busy so much, and That's that for me. Thank you guys for watching.